All right, so today we are going to talk about continuing our discussion about inequalities. We're going to talk about graphing linear inequalities. All right, so if you remember when we talked about um, graphing equations, okay, many of the equations we put into this form. And if you remember, this form here was called slope intercept form because the system itself, or I'm sorry, the equation itself had the slope, that's the m here, and the y-intercept. Okay, so that was the slope, and then the intercept was the b. Okay, now try to adjust here a little bit. Okay, so now what happens if this same equation, though, it becomes an inequality? So what does that mean, an inequality? Well, that means it's not equal, okay, or it's equal and something else. So in this case, instead of y being equal to 8/5 x minus 4, y is less than 8/5 x minus 4. But notice how in both cases, the 8/5 x minus 4 is exactly the same. The only difference is whether or not y is equal to it or y is less than it. So let's start here with just graphing this particular inequality, okay? We know that -4 is the y-intercept, so we can go down here 4, 1, 2, 3, 4, and we can put a dot there, okay? That is the point 0, -4. Okay, that's the y-intercept. Next, we can look at our slope, okay? The slope is rise over run. So we can go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we'll go over 5. 1, 2, 3, 4, 5. So that's up 8 over 5. Rise over run. Okay, now we have 2 points there. And we can connect the two by a straight line. I'm just going to use an envelope here because I don't have my ruler here handy. But this will do just fine. Okay. Now, what you'll notice, if we just left it as a line, that would be this equation. Okay. Y is equal to 8 over 5x minus 4. Now, that means that for every point on this line, there's an x and a y relationship such that when I plug in the x, it gives me the exact corresponding y, just like here. If I plug in 0 for x, my corresponding y is -4. If I plug in 0 for my x, my y becomes -4. 0 here times 8 over 5th is 0. 0 minus 4 is -4. Y is equal to -4. Now, in the case of here, what we're going to say when we plug in this 0 is 0 times 8 over 5th is 0. Minus 4 is -4. So nothing changes on this side. But notice the relationship. We're saying that y is less than -4, not equal to it. So how do we understand how to graph this? Well, once we determine our line, the next thing we need to determine is, do we want, are the units on this side of the line included, or are the units on this side of the line included? We don't know. So we need what's called a test point. And normally, if at all possible, I like to use the point here, 0, 0, as a test point because it's one of the easiest things to use. If I can plug in 0 for y and x, there's not a lot of math that I'll have to do. Okay, so let's take this point, the origin, which is 0, 0. We're going to plug in 0 for x and, and 0 for y and see if this relationship is true. Okay, so we'll plug in 0 for y less than 8/5 times x, which is 0, so times 0 minus 4. Okay? All right. 8/5 times 0 is 0. 0 minus 4 is a -4. Is 0 less than -4? It is not. That's false. So what that means is the point 0, 0 is not included in this. So all the points over here are. Now let me prove that to you. Let's pick something over here. So let's pick the point 1, 2, 3, 4, 5. Okay. The point 5 for my x, 0, because it doesn't go up anywhere. That's for my y. This point right here, does it make this true? Well, for my y, I'm going to do 0 less than 8/5 times x, which is 5, minus 4. The 5's here cancel. 8 minus 4 is 4. 0 is less than 4. That's true. So what that tells us is that all points over here on this side of the line will make this expression, this inequality, true. So we shade everything over here. Okay? Now, the other thing we need to understand is this line right here, all the points in this line create an equal relationship, not a less than. And I don't have a line here to say less than and equal to. So because of that, this is not a solid line. This is actually a dashed line. So the dashed line is what indicates that they're not equal. Okay, not equal to 8/5 x minus 4. Now, it could be that everything on this side or everything on this side. Obviously, since we shaded over here, it's everything less than. So we have a dashed line here and everything over here shaded. Okay? And that is an inequality. So let's look at another one just like that. Different numbers, but essentially the same idea. So let's look at the expression, or the inequality, I'm sorry. Y is greater than or equal to 1/2 x plus 3. Okay? So we are going to graph this. The y-intercept is positive 3, so 1, 2, 3. Slope is 1/2, so rise of 1, run of 2. Rise of 1, run of 2 more. Rise of 1, run of 2 more. Now, is this a dashed line? No, because even though it says greater than, it also has this equal to sign, meaning that it can also be on the line. So it'll actually be a solid line. Now all we have to figure out is, are we shading below the line or above the line? Now, when you see that greater than, your first instinct is above the line, but always double check. Okay, so let's plug in the point 0, 0. Okay, so if we do that, we have 0 greater than or equal to 1/2 times 0 plus 3. 1/2 times 0 is 0. 0 plus 3 is 3. 0 is greater than or equal to 3. And that is true. 0 is greater than or equal to 3. So that is true, meaning that we shade because it's included. I'm sorry, what am I saying? That's false. 0 is not greater than or equal to 3. So we don't shade this bottom part, we shade the top part. And if you want to prove it to yourself, you can. You can plug in one of these numbers there to show yourself that that is true. All right, let's look at another one. Here we have x is less than or equal to -1. And we looked at that yesterday on a single number line. So I'm going to show you how to put that on a double number line. Okay, so here's your x-axis, and we have the point here, -1. So we know that x is less than or equal to -1. That means it includes 1, and x is everything to the left of 1. But what do we do once we include a y-axis, right? Notice that if I take some number, um, let's say this point up here that has -1. Let's say this is 0, 1, 2, 3, 4. So this point right here is -1, +4. Okay. Is this included? Well, let's look. The x value is less than or equal to -1, but the y value is 4. But notice how the equation doesn't care about the y value. It only cares about the x value. So any x value that's less than or equal to -1 will work. So this point works. In fact, every -1 point will work. So you actually have a line that goes straight up here. These are all the -1 points, and everything on this side of -1 will make that inequality true. So it's a straight up and down line at -1, and everything on the left side is filled in. Right. Now let's look at y is greater than or equal to -1/4 times x minus 4. Okay, so here I have x, y. I know that my y-intercept is -4, so -1, 2, 3, 4. That's right here. And then I have a slope of -1, 4, meaning I go down 1 and I go to the right 4. 1, 2, 3, 4. There's that point there. I can also go up 1 and to the left 4. 1, 2, 3, 4. That's +1, -4. And remember, -1, right, going down 1 and over to the right 4 is the same thing as going up 1 and to the left 4, because they both are -1/4. So if I go to the left, I'm sorry, if I go up 1 and over to the left 4, that's right there. So those are my 3 points. This is greater than or equal to, so it's going to be a solid line. If I check the point 0, 0, I have 0 is less than or equal to, this will multiply to 0, minus 4 would give me -4. 0 is greater than -4. That is true. So it's everything on top here. Everything above this line. Okay. All right. Now let's move on to graphing absolute value equations. Okay, so let's start out with a real basic one. Y is equal to the absolute value of x. Okay, now from here we know, let's just draw a little xy criteria here, right? I can plug in 3, 2, 1, 0. Then let's also plug in -1, -2, and -3. All right, if I plug in 3 for x, the absolute value of 3 is 3. Absolute value of 2 would be 2. Absolute value of 1 would be 1. Of 0 would be 0. If I plug in -1 for x, the absolute value of -1 would be 1. The absolute value of -2 would be 2. And the absolute value of -3 would be 3. Now I do this because now what I'm going to do is I'm going to graph it based on these points. So 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. 1, 2, 3, 2, 3, -2, -3, -1, -2, -3. All right. So my first point is 3, 3. So 3, 3 right here. Good. 2, 2, 1, 1, 0, 0. -1, +1. So -1, +1. -2, +2. -2, +2. -3, +3. All right, so this is my graph. It creates kind of this corner, right? And that's what the absolute value equation is going to yield. It's going to yield this very sharp corner right here going off on 45-degree angles. All right, so now that we know kind of what the base graph looks like, let's look at a few other things about this graph. So what I'm going to do here, y is equal to the absolute value of x minus 3 plus 3. So what is this going to do? So we're going to kind of do the same thing, all right? I'm going to plug in x and y. All right, I'm going to plug in 0, 1, 2, 3. Now, instead of going negative, I'm going to plug in 4, 5, 6 because I want to show you something here. All right, so if I plug in 0 here, 0 minus 3 is -3. The absolute value of -3 is 3, and 3 plus 3 is 6. Okay? If I plug in, 1. 1 minus 3 is -2. The absolute value of -2 is +2. Plus 3 would give me 5. If I plug in 2, 2 minus 3 is -1. The absolute value of -1 is +1. 1 plus 3 is 4. Now I'm going to plug in 3. 3 minus 3 is 0. Absolute value of 0 is 0. 0 plus 3 is 3. Now let's do 4. 4 minus 3 is 1. Absolute value of 1 is 1. 1 plus 3 is 4. Now 5. 5 minus 3 is 2. Absolute value of 2 is 2, plus 3 is 5. Now 6. 6 minus 3 is 3. Absolute value of 3 is 3, plus 3 is 6. So now when I go to I don't have any negatives, so that's why I'm only drawing the first quadrant here. 1, 2, 3, 4, 5, 6. 1, 3, 4, 5, 6. All right. 0, positive 6. All right. 1, 5. 2, 4. 3, 3. 4, 4. 5, 5. 6, 6. So notice we have the same shape, but this origin has moved on us, right? I'm sorry, this vertex here, this point has kind of moved on us. Right here was right at the center, right? Y is equal to the absolute value of x. But when we change it to the absolute value of x minus 3 and plus 3, it moves. Let's look at where it moved, okay? So it started, remember the original, we look here, was right here at the origin. So it started here at the origin. Then it moved to the right 3, and it moved up 3, right? Or you can say it moved up 3 and to the right 3. Either way, it moved to right there. It moved over 3 and up 3. Notice that those are the same numbers here. So if we have an absolute value and we add a number to it, that's how far up we are going to shift that vertex point. Now with the x, it's a little trickier because notice this is a minus, which would make you think that we would move to the left. But in fact, it moves it to the right. Why? Because this becomes 0 at x at positive 3. Notice this point right here is our 0, 0 point. So how do we get there? Well, x has to be a positive 3 for this to be 0. Now we're at our 0 point, and then we're going to add 3, so that's what shifts us up there. So in order to make this 0, that x would have to be 3. All right, so you can kind of see how that absolute value works. Okay, let's do another one. Let's do y is equal to the absolute value of x minus 3 minus 1. Now, we can do what we've been doing, right? We can make a little chart of x and y, and you can do all your numbers. Or what we can do is understand that this number and this number are going to shift me. If I know essentially what my typical graph looks like for y is equal to the absolute value of x, I'm going to shift this graph on the y-axis by -1. So I know I'm going to come down right there. Then I'm going to shift on the x-axis by 3, right? Because what's going on here is that for this to be 0, x would have to be positive 3. So 1, 2, 3. I'm going to go down here and over to 3. So this is going to be my new origin point. It's going to be the exact same graph. So I'm still going to have same exact graph. It's just going to be shifted. Now we could verify this, right? We could put x and y, and you could put, -1, -2, 0, 1, 2, and see what those are, plug those in, put your dots on there, and create your graph. Either way is fine. Okay? All right. Let's do another example. y is equal to, let's just do the absolute value of x minus 3. I'm going to do this one the way I did the last one. I know my general y is equal to the absolute value of x without the negative 3 is this. And all I'm doing here is I'm shifting it down 1, 2, 3 on the y-axis. Remember, this up and down right here is my y. This left and right is my x. So my graph is exactly like this, just shifted down. All right, let's do another one. Let's do y is equal to the absolute value of x minus 4, and that's it. So here, notice that I don't have any shifting going on the y-axis. I'd have to add or subtract something over there. So we're going to stay on the x-axis. We know that this is the original looking graph. Okay. But we're going to shift it to the right 4. 1, 2, 3, 4. Because if I plug 4 in, that gives me 0. There we go. All right. And that is graphing inequalities and the absolute value.